very specific, predefined questions, right? And so this is more of a very clear hypothesis testing question where we have a well-framed, very specific question using the PyCords framework. I will talk about the PyCords in the next few slides. Then category 2 is where we have a question. We don't have a real research question that is well-defined. It's a very broad question. And the aim here is more of exploratory. And so the kind of reviews we'll need for that will obviously be different as well. And then in the third category, we don't actually have a question at all. We're just trying to quickly provide an overview of the available evidence, like a quick and dirty review of what exists. So the kinds of reviews that exist are a function of these 3 categories. Now let's focus on this first category where we have specific predefined questions. Now, when that is the case, the question we have to ask is, what kind of synthesis are we trying to achieve? Are we trying to do a qualitative synthesis of the data, which means we're just trying to summarize the data or synthesize the data without clear quantitative insights? Or are we trying to do more of a quantitative synthesis of the data? If the answer is qualitative, then what we have is a narrative review. We'll discuss that, briefly, what that entails. But essentially, narrative review is we're just trying to summarize the findings without following a strict methodology for inclusion or exclusion criteria for the study. So that's what we mean by qualitative. And then sometimes we want to have a more quantitative synthesis of the data. And so by that, we mean that you have a comprehensive structured synthesis. There is rigorous and predefined methodology for how you are going to include studies in the review. So now, if we have decided that that's the path we want to take, the next question we want to ask is, how are we pulling the data? Like, how are we analyzing the data? Sure, we're saying it's quantitative, but what does that exactly mean? If quantitative means that we are going to use a statistical method to create an average of all the studies, so that means that we'll come up with one number that will say, we take this study 1, study 2, study 3, and we average them together to give one number that represents all the study, which is like the average effect. Then we'll call that a meta-analysis. Meta means after, like, metamorphosis means, change after formation. Meta-analysis means the analysis after the analysis, right? So in this case, we are taking the data and we are actually analyzing them quantitatively to give us one summary metric. Now, if we are interested in quantitative measures, but not necessarily in terms of calculating an average, we call that a systematic review. So in this case, we are still interested in quantitative synthesis, but in this case, we will talk more about the ranges that, the range of this effect range from so to so. We're not necessarily summarizing all of the studies to give us one number. So that's the major difference that exists between meta-analysis versus systematic review. It is essentially, are we statistically pulling the results together? So this is the flow we have when we have a specific predefined question. Again, we first of all ask ourselves whether the synthesis is qualitative or quantitative. If it's qualitative in this context means just summary. We're just trying to summarize the results, like, this result showed from this study showed so and so, and this study shows so and so. It's just a summary, a large overview. Then that's a narrative. It's like somebody narrating a story. Think of it that way. But if it's quantitative, then it can be meta-analysis if we are going to pull the data from all different studies together to give us one average result. Or if we're not going to do that, then it's a systematic review. All right. So again, to provide more flesh on what we just covered. So most of you already know of a narrative review as a literature review. So when you do a literature review, what essentially you're doing is doing what we call a narrative review. And here are the hallmarks of a narrative review. It is informal, it is unsystematic, it is subjective, right? I'm sure all of you have written a proposal or a thesis or a dissertation, and so you should be very familiar that it is obviously inherently very subjective. And what that means is that if you pick two individuals to do a narrative review on the same subject, their results will be completely different, right? So that's why we say it is unsystematic. Systematic in terms of research means that there is an element of reproducibility, right? It follows a well-established pattern or an approach such that if you did it and I did it, we should get the same results. But in narrative review, you are not going to find that because it's inherently subjective and informal and unsystematic. There is no comprehensive searching. There is no quality appraisal. It's very prone to cherry picking. People just pick the results that they want. In terms of sampling, it's like convenient sampling, if we want to use that as an analogy. And so because of this, there is a large risk of author bias and selection bias. Again, because of what is convenient, somebody is feeling very lazy, they just picked the first papers they saw and wrote it as a literature review. And so those are some of the challenges with a narrative review, also called a literature review. So then let's talk about a systematic review. A systematic review is a scientific investigation that seeks to address some of the problems that we mentioned with a narrative review. Here, the objectives are clearly stated. We have predefined eligibility criteria for studies that are going to be included in the study. And the whole idea behind a systematic review is to make it reproducible so that if you did it and I did it, we should be able to get the same results. And so largely, systematic review seeks to address some of the limitations that we established previously in a narrative review. So if we contrast a narrative review with a systematic review, we can see that a narrative review tends to be subjective, whereas a systematic review tends to be more objective. The research question in narrative review is broader. Imagine you're doing a thesis and you have to look at factors associated with cigarette smoking in Saudi Arabia. That's a very broad research question. I mean, it's a question, but it's very broad. And so those are the kind of elements that fit themselves more to narrative reviews, whereas a systematic review is much narrower. What is the association between smoking and lung cancer, right? That's a very narrow research question. The methods in a narrative review are unclear. Like we said earlier, it is very subjective, it is unsystematic, and so it tends not to be reproducible. In a systematic review, the methods are clearly defined. For a narrative review, it's like convenient sampling. So not all relevant literature are included, whereas systematic review clearly establishes inclusion and exclusion criteria to ensure that all relevant literature are included. And then there's no appraisal. Appraisal means assessment of quality, and we're going to talk more about that, next few slides. So in narrative review, you just pick the studies and just summarize them and just add. It's even worse now in the age of AI, where you have all these platforms that just say, oh, you just put a topic and they just grab whatever studies they find and just write your report, and you are happy with it, right? There's no critical appraisal going on, no quality assurance, no review of the evidence, right? Those are some of the challenges with narrative reviews that you might have, whereas in systematic reviews, you have appraisal of the quality of evidence. So why do we do a systematic review? Well, we do it to answer research questions, especially when we have what we call equipoise. Equipoise means we are in a state of scientific knowledge where we don't know whether to go left or to go right. Do e-cigarettes protect or do they harm smokers? Is coffee good or bad for your health, right? Sometimes we come to a state of knowledge where you have conflicting results in the literature. And so the point of a systematic review really is to look at all of the evidence together and help us to narrow down a concrete answer and reduce confusion. So that is essentially when we really, really need to do systematic reviews, when we have equipoise in the literature. And so the goal is to find a summary of the results and highlight areas where there is not enough evidence, and also identify gaps that can be used to guide future research. So this is an example of a systematic review that my team and I did, systematic review of outbreaks of COVID-19 within households in the EU region when the child is an index case. And so just to quickly highlight that to see how we appraise the studies, let me quickly show that particular study and how we present the results in such studies. So so here, this is the study in question. You can see there's a clear search strategy and selection criteria. This is an inherent hallmark of systematic reviews, right? You have to tell us how did you define the inclusion criteria or the exclusion criteria for your study? How were studies included, right? So this is what we mean by there's clear research question. The research question is here is very clear. The aim of this systematic review is to identify the secondary attack rates of adults and other children when children are the index cases within households in Europe up to January 2020. So it's a very well-defined research question. And then you have a very well-defined search strategy and inclusion criteria. And then you have a flow. We're going to talk more about this. But again, this is to indicate how you got about the results. Remember that the goal is to ensure reproducibility. How did you end up with 19 studies? So that if the next guy wants to do it, he also or she also will end up with 19 studies. So you have to tell us, okay, what are databases you searched? So here we searched, for example, Medline and Embase. Like how many studies did you find? How many were duplicates that you removed? How many studies did you screen? How many did you exclude from screening? How many did you include for retrieval? And how many did you finally include in the study based on the inclusion criteria that you had set up? The whole point of this is to make sure that there's a clear and reproducible methodology so that other people, if they were to follow that same methodology, they will get the same results. So how do we report results from systematic reviews? Well, typically remember I was said that it's a quantitative method of analysis, but we are not trying to generate an average result. So we report the different results. It's like, think of it as descriptive analysis. So different studies are reported, in tabular form, like this, or in graphical form, right? Where you can report the different studies and the magnitude of results seen. At the end of this session, we're going to try and see how we can create figures like this and how we can report. But the goal here is to show that systematic reviews are a quantitative form of synthesizing data where we are not necessarily producing one summary result, right? The results are still presented quantitatively, but we don't have one summary that says this is the average of all the results. So this is what we mean by a systematic review. So let's go back to our slides. So again, you can see that this is quite different from more of a narrative review. Let me show an example of a narrative review. This is a narrative review we did to look at the impact of reporting or HTA assessments. I want us to contrast the methodology we looked at in the systematic review with the one we used here in this study, right? Again, research question is different, it's broader, and you will see how the methodology differs again from when we have a narrative review versus when we have a more of a systematic review. So here, for example, let's see how studies were selected for this particular investigation. So let's see. Let's scroll up here. All right, so this is the review of actual evaluations by the German HTA agency and associated exploratory analysis. So HTA agencies are government agencies that are responsible for reimbursement of treatments, for specific treatment or interventions. So, but the point we want to really focus on here is not necessarily what HTA agencies are. We just want to focus on here how studies were selected here so that we can contrast what happens in the systematic review with what happens more in an exploratory or narrative review. So here, let's start here. Let me just go specifically to where we're interested in. So here, let's start from here. We identified the clinical trials considered by the GBA during each, GBA, by the way, means the German HTA agency, during each evaluation, and determine whether the entire study population from any relevant clinical trial was included in the evaluation, or instead subsets of the entire study population. We compare the patient numbers with the total size of original trials. Beyond this, okay, let's skip that part, it's not important. Then here, this is the crux of the argument here. Therefore, we chose 5 HTA evaluations from different sponsors, again, because we realized that the indications for treatments might differ by different things, like the kind of condition the patient has and many other factors. Therefore, we chose 5 HTA evaluations from different sponsors and for different therapeutic areas that were based on subpopulations of the originating clinical trial subpopulation, and so on. The point I'm trying to make here is that there are thousands upon thousands of HTA evaluations. And from those thousands, just five were selected. Now, of course, the 5 is very arbitrary, right? If you brought another investigative team, they will select another 5. And so you can see here that there's almost always a risk for investigator bias. In this case, maybe the investigators want to tell a particular story, and so you might have a lot of cherry picking that could emerge. I'm not saying that's what happened here, but I'm saying that there's always that risk when you have just more of a narrative review, because you're not examining the whole evidence. You're just selecting based on very arbitrary criteria, right? So that is one of the challenges when you have a narrative review. And so we obviously want to be aware of those so that when we interpret results from narrative reviews, we should do so appropriately. I think also another reason why we want to know the types, why we're emphasizing on the type, is that when we as investigators report things, we should not label a study that was a narrative review as a systematic review. That's obviously wrong, right? Because that might be misleading. If you did a narrative review, you should call it a narrative review. If you did a systematic review, you should call it a systematic review. So we need to understand the different types of reviews so that we don't by mistake misclassify the kind of study we're doing. All right, let's move on to meta-analysis. So meta-analysis is a quantitative way of reviewing data that seeks to give us one summary result from all the studies. And again, difference between a meta-analysis and a systematic review is that both are quantitative in nature. However, a systematic review doesn't try to give us one number as the summary of all the studies we are looking at. A meta-analysis seeks to do exactly that. And so it is like the gold standard for research, because it seeks to give us one number from all the studies and considers extensively issues of bias. And so how do we do it? Well, you want to be very exhaustive. Again, if you're doing a meta-analysis, as you have with the systematic review, the goal is to include all studies that meet the inclusion criteria, not just the subset, not just arbitrary selection of studies that you want to include. And so we sometimes use the funnel plot to assess the completeness. And of course, meta-analysis include very high and stringent levels of quality assurance to make sure that the studies that are included indeed meet the inclusion criteria and as well as the exclusion criteria as well. We present results from meta-analysis graphically and tabularly with narrative commentary. And so the whole idea of the analysis is to actually apply measures of aggregation. We want to aggregate the data and produce one single number that summarizes the effects of the studies. This is an example of a meta-analysis in the Surgeon General's report. When the Surgeon General's report comes out and says that there is a causal effect between smoking and whatever health outcome, that claim is often backed by extensive meta-analysis where we've taken all the studies and we've pulled them together to produce one summary estimate. So here, for example, this is a meta-analysis of death from any cause. And you can see this on the left-hand side here. These are the studies that were evaluated. So you have the British doctor study, the Men in 9 State study, and so on. This is what we call a forest plot. And on the forest plot here, you can see that there is a line in the middle, which is a null value. The null value in this case is 1.0. Why is it 1.0? Because we're using incidence rate ratios. So a ratio has a null value of 1. So 4/4 is 1, meaning that the number at the top and the number at the bottom are the same. So that means that when the direction of a result is to the left-hand side or less than 1, we say that the exposure is protective. If it is on the right-hand side or more than 1, we say that it is harmful. So here we see that there is all of the results clearly are to the right-hand side, meaning that smoking increases the risk of, all-cause mortality, right? So you can see all the individual results. The British doctors, you can see the result here, and all the other studies, you can see their individual results here. The width of the confidence intervals tells us how precise the estimates are. So that is an indication of the sample size in the original studies. And you have here this rhomboid here. This is a summary. This is now a quantitative summary of all of the studies, right? And so you can see that we can say that when we pull all the evidence together, it's consistent with all the individual studies. And so this takes us back to Hill's criteria of causality, where we'll talk about things like consistency. Consistency means that all the studies are telling us the same story. So you can see that is clearly made here, right? You can see all the studies clearly have a incidence ratio more than 1.5 or more larger than 1, all in the same direction. And that's why you see the pooled is also around 1.6 or thereabout there, 1.65. All right. And so that tells us, that's what we mean by consistency, right? Because all the studies are telling us the same story. So this is why we do a meta-analysis, to come up with a single estimate, right, that summarizes all of the other studies and tells us what the effect is. Now, when we're doing systematic reviews or meta-analysis, there are some things we want to be mindful. Tosin, can you please mute yourself? There are some things we want to be mindful of. One, we want to be mindful that studies can vary in quality. And sometimes, we might think we're doing a systematic review, but it may not be very systematic if it's not well documented, or if there's subjectivity in how we're approaching it. So we want to make sure that it is truly systematic. The reason why we call it the systematic review is because it is done systematically, meaning that it's reproducible. So if that's not the case, then maybe that's not a systematic review after all. And sometimes systematic reviews take such a long time that by the time you're done, other new studies have been published. And so you might have to then update the evidence. So that's also one of the challenges that you might face. It may not include all studies. The goal is to include all studies, right? All studies published on that topic. But what if the studies are published in Chinese and you cannot read Chinese? What if, so it could be published in non-English languages or languages you cannot speak. There could also be from the gray literature, studies that have been published by other agencies, but not necessarily peer-reviewed, or early literature. We're talking about preprints. Sometimes you publish things in preprints that has not undergone peer review yet. If the inclusion criteria does not include that, then you are losing out on all of that evidence. Ideally, you want to include all studies on that topic. You want to include a sensitivity analysis, at least, where you also include gray literature. And if possible, you want to include all languages. But sometimes it's just not logistically possible to do that. And so you can have some risk of bias in that context. And so while systematic reviews and meta-analysis are designed to be objective, the problem is that sometimes the quality assessment measures are subjective. So remember that it's human beings that are assessing the quality of the evidence. And so subjectivity could creep in from that area. The method used may not be clear. The individuals or the researchers may not have searched all possible databases. And please note that Google and Google Scholar are not considered databases for the context of systematic reviews, right? And so you don't want to just search one database. You don't just want to search PubMed alone, for example, right? That is not sufficient. So if you did a systematic review and you just searched one database, PubMed, for example, is owned by the US government. And so obviously there is a preponderance of American journals in PubMed. And so you might have journals from other parts of the world, for example, journals from Africa that may not necessarily be represented in PubMed to the same extent as American journals. So you now have a problem when you restrict your systematic review only based on articles in PubMed. How do you know you've captured all the studies that are out there? So that is why we recommend that you cannot just use one database to capture studies that are eligible for your review. You want to capture at least two databases. And again, Google and Google Scholar are not considered databases. Another challenge is that the measures of disease burden and association are different in different studies. And so that in of itself is not a problem. The problem, however, arises where the investigators are not very savvy in terms of science and do not even realize that the difference in disease measures of association could influence results, right? So there is need for you as the investigator to really be up to date on what the different types of measures of association are, and importantly also how you can convert one from one to the other. So let's look quickly at some of the different measures of association that we use in studies. They could broadly be classified on the ratio scale or on the difference scale. So on the ratio scale, we have things like prevalence ratios, odds ratios, risk ratios, also called relative risk, hazard ratios, or incidence rate ratios. I'm sure we're all familiar with the ratio scale. However, studies could also use, there's no rule that says you must use a ratio scale. So investigators could have chosen to report things on the different scale. So you could have prevalence difference, you have risk difference, also called excess risk or attributable risk. Or they could have reported population risk difference, also called population excess risk or population attributable risk. So imagine a scenario where this investigator is doing a systematic review and they come across some studies in which they published risk ratios and others in which they published risk difference. And you somehow, knowingly or unknowingly, just treated all of them as the same. That's a huge problem because you're comparing apples to oranges. So what you need to do is to first of all standardize all of them to one measure so that you are comparing apples to apples or oranges to oranges. So these are very familiar. So let's quickly explain what this means, because these are less familiar or less used in the routine literature. So let's quickly talk about what those mean. So here, let's look at an outcome. Let's imagine this is cancer, lung cancer. And so we have three groups here: smokers, who are the exposed individuals. We have non-smokers, who are the non-exposed. And then you have the population, which is the average of smokers and non-smokers, right? These are the three groups that we have. The risk among the non-exposed, which is the non-smokers, is called the baseline risk, right? That's what we call the baseline risk. And it's called baseline risk because it acknowledges the fact that, well, even if you are not exposed, you are still at risk, right? There is no such thing as zero risk. So even people who have never smoked a cigarette in their life may still end up getting lung cancer, right? So it's not all of lung cancer cases that come from smokers. So this risk that comes from non-smokers or the non-exposed is what we call the baseline risk. So if we now look at the risk of the exposed and divide it into A and B, anything above the baseline risk is what we call the excess risk. Why do we call it excess risk? Well, it is excess of the baseline risk. We also call it the risk difference. In other words, this part above is equal to the risk among the exposed minus the risk among non-exposed, which is what gives you portion A here, which is the excess risk. Excess risk comes in different names, but they mean the exact same thing. It is also called attributable risk. It is also called excess risk. It is also called the risk difference. Now, sometimes in other studies, you might see they will report something that sounds slightly different. Instead of calling it attributable risk, they might call it attributable risk percentage. And those are two different things. Attributable risk percentage is simply expressing the risk up here as a percentage of the entire risk here. So it's simply put, attributable risk percentage is A divided by B, divided by A plus B times 100. So let me correct this here. So we're saying this is A divided by all of this, right? So in other words, how much of the excess risk expressed as a percentage of all of this? And that gives us what we call the attributable risk percentage. So again, remember that the attributable risk is just the part up here, A. But when we express the attributable risk as a percentage of the entire bar, then we call it attributable risk percentage, or excess risk percentage. Again, why do we need to know this? Well, because you're doing a systematic review. And so one study might express the results in excess risk or attributable risk. Another study might express it in an entirely different way as attributable risk percentage. Another might express it as odds ratios. It is your job to know those differences and to be able to standardize all of those different measures into one standard measure so that you're not comparing apples with oranges. So that is what we mean by, attributable risk and attributable risk percentage. And then we also have a different construct, which is it's the exact same philosophy as we discussed here. It's just that this time we're looking at this bar for the population overall, right? And so portion A here, we just add population in front of the attributable risk, and so we'll call it the population attributable risk, or the population excess risk, or the population risk difference, right? It is simply the risk that is in the population above the baseline risk, right? So those three things mean the exact same thing. But again, want to emphasize, you need to know this again because studies might express it in different ways. It's not all studies that report odds ratios, right? And so it becomes your job to know the difference so that you have to standardize everything so that you're not comparing apples to oranges. And the same thing here, let's correct this again. A, all over A plus B, we're measuring a risk in the risk at the top expressed as the entire bar here. So we're saying this part at the top here, what percentage of the entire bar is it? So that is A divided by A plus B times 100. And that gives us the population attributable risk percentage or the population excess risk percentage, all right? So you should be able to quickly visualize these things. You should be able to, when you see different metrics used in different studies, be able to easily just convert it from one form to the other so that you are reporting in one consistent metric. How are you going to compare two studies when one measured it in odds ratios or in relative risks, and another one measured it in in risk difference? I will share with you a calculator at the end of the class that will allow you to be able to convert easily from odds ratios to relative risks, or from risk differences to relative risk, or in between, so that you can be able to, you should be able to try your hand, play with that a lot and see how you can do that. Again, this is extremely important. I can't emphasize that enough. Don't just grab results from different studies and just start comparing them. That makes no sense. All right, so we've talked about the scenario where we have specific predefined questions. Now, sometimes we have broad exploratory aims that are not specific, like the first scenario. So here, the question we want to ask is the review comprehensive with a broad search strategy? If the answer is yes, then that's a mapping review. Like, think of a map. A map literally seeks to map all the features in an area and put them on a map or on the surface so that we can know, okay, this is where this one is, and this is where that one is. That's essentially what the mapping review seeks to do. It seeks to provide an overview of a broad research field and map the existing literature without necessarily doing any detailed analysis of what we have observed. A scoping review, however, seeks to explore the scope of research to identify gaps and summarize evidence. So it is less broad compared to a mapping review, and the aims and objectives are quite different. So again, like we said earlier, some of the challenges with a mapping review is that there is no formal quality assessment. You're just trying to map all the different studies in that field, and so there may not be formal quality assessment. We typically present the results in tables and in figures, as a summary might be. But as you can see, since you don't have any quality assessment, any formal quality assessment, there's a lot of risk from subjectivity of the whole experience. So this is an example. Of course, you can look at PubMed and review thousands of examples that exist for mapping review. Again, scoping review is also subject to the same biases because there is no formal quality assessment again, right? So because of that, there is the risk for subjectivity that could also creep in. And again, like the other reviews that are very subjective, report them in the form of narrative as well as with tables or figures, as the case might be. And again, you can look at PubMed to look at different examples of that as well. And then sometimes we don't even have a research question at all. We just want to see what even exists out there. Like, it's not as if I have a research question. It's like, what is out there? There's no question driving the search. And that's what we call the rapid review. It's a very quick and dirty review to just see what's out there. And so we do it when we have, a very urgent issue. We are so busy, we don't have time to come up with hypotheses, but we just want to see what exists out there. And so that is the context in which it's done. An example here, you have, COVID-19, we're trying to see what are some of the urgent issues that we need to address, right? Or whatever the context might be, then that lends itself to a rapid review. And generally, we don't spend so much time on rapid reviews. We don't spend so much effort. We're not trying to review two databases. We might just look at PubMed only. We might just have one person review. There's no standardization. There's no allocation of multiple members on the team to review because it's rapid. We acknowledge that it's quick and dirty. And so it has, it's just think of it as a pedestal on which we can then come up with hypotheses and say, all right, let's do a more detailed review or let's conduct a study. It's just meant to give us a back of the envelope kind of feel for what the data is out there. So, so from the most systematic to the least systematic method, of course, meta-analysis is at the top because it's very systematic. It's meant to be reproducible, and it also involves a quantitative analysis of the data where we're trying to generate one estimate. All right, there are guidelines we need to follow when we're reporting systematic reviews, and that differs by kind of studies. For example, I'm sure you're all familiar with PRISMA, which is the reporting for systematic reviews. For other types of studies, there are other guidelines, but essentially the goal is that there has to be a checklist, there has to be a guide. You can't just decide to do it your way. In terms of what do we report, how do you report it? Those are all governed by guidelines. So this is a checklist by PRISMA. I've also provided the link at the bottom to guide you to access it. There's a flow which indicates there's a guidance on how you should report, how studies were eventually included, like I showed you in the other study. And again, this is part of a checklist. All right, so what are some of the steps in a systematic review? Now that we've looked at different types of reviews, what are some of the steps that you want to take when doing a systematic review? Well, first of all, you want to assess the need for a systematic review. Do you really need to do a systematic review? I'm going to talk more about some of this in the next few slides. If there's a need for it, you assemble the systematic review team, you develop your research question, you define your inclusion and exclusion criteria, you develop the protocol. That's very important because we don't want to move the goalposts. A protocol is like a contract between you and the research team that says, this is what exactly we're going to do. And everything has to be done per protocol. And so that's very, very important. You locate the studies, you do an abstract and full text review, you assess the study quality, you extract data, you analyze and interpret results. If needed, you update the review and you write your systematic review. So these are some of the steps. So I'll just take some of those steps and explain them in some detail so that we're all on the same page. So the first one was assess the need for a systematic review. Like we said earlier, the most important need or the use case for systematic review is when we have equipoise. All the studies are pointing in different directions. Is it this way or is that way? Like, that is when we need a systematic review the most to help us summarize all of this data and show us the way that we should go. And so that is the indication for systematic review. Now, remember we said that both systematic reviews and meta-analysis have well-defined research questions. So what do we mean by a well-defined research question? Well, a research question is well-defined when it follows elements of PICO or PICOTS. PICOTS is a framework that we use in research to ensure that our research questions are very well-defined. It's an acronym. P stands for population, I stands for intervention, C stands for comparison, O for outcome, T for time, and S for study design. In observational studies, we change the I for E. We swap out I and put E. Interventional studies only apply to experiments because we are intervening. We don't have interventions in observational studies, right? So we use E for exposure. Every intervention is an exposure, but not every exposure is an intervention. So exposure is a broader term that also includes interventions, but interventions is very specific to experiments. So a research question is well defined if it has all the elements of PyCodes in it. So when we say your research question is poorly defined, what makes a research question poorly defined? Well, your research question is not well defined if it has any of these elements. One, if it's fuzzy. A fuzzy research question has one or more of the elements of PyCode missing. So for example, it does not include the population or the intervention or the control group, right? It's very broad. It's like this image here. It's like, oh, it's not very well defined. So for your research question to be well defined, you need to include the elements of PyCode. So for example, if I simply say, what is the impact of tobacco use on cancer? That is a very fuzzy question. What do I mean by tobacco use? Do I mean cigarette smoking? Do I mean cigar smoking? Do I mean any kind of tobacco use? What do I mean by cancer? What kind of cancer? Is it lung cancer? Is it? And then among who? Am I talking about everybody alive? Am I talking about, adults? Am I talking about American adults? Again, those are details that we need to put into the research question. So it's not appropriate to just say, what is the impact of tobacco use on cancer? A better question would be, what is the association between cigarette smoking and, clinically diagnosed lung cancer among adults or American adults during this time period? Now, see that question now becomes more better framed because all the elements of PyCode are in there: the population, the exposure, the comparison, the outcome, and the time. So your question is poorly defined if it doesn't have those elements of PyCode in it, or PyCodes, as the case might be. A second issue that might make your research question poor or poorly framed is what we call the no question question. Here, there is no question at all. It's like an essay. And by the way, for something to be a question, it must have a question mark at the end. So if you just make a declarative statement like tobacco use among adults in South Africa, that is not a question. That's just a statement. A question has to be investigative in nature. It's trying to find out something, right? And so when you frame your research questions as declarations, that is a no question question because you've not even told us anything that you're trying to investigate. So a question must have a question mark at the end of it. And then you have TMQ. This is a spin-off on TMI, too much information. Well, you can also have too much questions or too many questions. So here, instead of having one well-defined question, you have like 3 questions or 4 questions. Like, what is the association between cigarette smoking and lung cancer? And how does exposure to asbestos influence the risk of tuberculosis? Okay, each of those 2 things could be a different research question in of itself, right? We live in an age where people cannot read a lot of material. So when you include so many research questions in one question, it makes it harder for you to present the information in a clear and coherent way. And it makes it harder for your audience to read through, right? So one research question, one paper. If you want to have 2 questions, you can split them into 2 different papers or reviews. And then sometimes the unanswerable question. Obviously, if it's a systematic review, it assumes that there are studies that exist on that topic that you're reviewing. If you are proposing a systematic review on a brand new topic that does not exist, that's an unanswerable question. Perhaps you're using the wrong study design. Perhaps we should not be talking about systematic reviews. We should be talking about maybe much earlier study designs, like maybe a cross-sectional study or maybe maybe another analytic study that is obviously not a systematic review. So ensure that you have ample evidence, ample studies published on the topic. Otherwise, your study becomes unanswerable from a perspective of a systematic review. And then the recycled question. We already know the answer. Like, why are you telling us that? So many studies have been done on that. So many systematic reviews have been done. Remember, we said that a systematic review best serves us when we have equipoise. Equipoise is when we don't know whether the direction is left or right, or is it this direction? We don't know. And so a systematic review or meta-analysis is supposed to help guide us towards a clear direction where we should go. But if we already know the direction, why are you doing a systematic review again? You are simply just rehashing things that we already know. And so your study is neither interesting nor novel. And then sometimes we have the last question, which is the so what question. These questions might have a lot of methodologic finery and a lot of fancy stuff in there, but it doesn't really tell us, it doesn't move us from point A to point B, right? And so again, impact in real world context means that your study can move the needle on policy or on practice of public health. And so it's not enough to just do a systematic review just because you have time or just because you have, it should fill a gap in knowledge, And so if it doesn't, then it becomes a so what question. So framing your question well means that you should take cognizance of these 6 factors and use them to deploy them accordingly. Again, one of the other steps we said, once you define your research question, then the next thing is to define your inclusion and exclusion criteria. One of the mistakes you see people do is that they think that inclusion and exclusion criteria are opposites of each other. So you might see people say inclusion criteria was adults older than 18 years old. Of course, this is not a systematic review now, but we're talking about in general now. They might say adults aged 18 years or older, where that was the inclusion criteria. Then the exclusion criteria, they will now tell you people younger than 18 years old. So it's almost as if they're saying that inclusion criteria and exclusion criteria are opposites of each other. They are not. So let's explain what those 2 terms mean. Inclusion criteria is like you put your arms around the population and say, everybody that falls within my arms is included in the study. That is what the inclusion criteria is. In our illustration here, it's a green line. We've put our arms around and said, okay, everybody here is part of the inclusion criteria. If you fall inside this cycle, you are part of the inclusion criteria. If you are not inside the cycle, you did not meet the inclusion criteria. Now, after we've done that, we now look into the cycle and say, there are still some people that we just have to remove from inside the cycle out, right? So in the context of a systematic review, we specify our inclusion criteria, for example, based on the type of intervention or the activity or the outcome or the population or any of the PICO elements, right? And then we can now say, well, while you are in the cycle of trust, we still have to remove you because I can't speak Chinese or I can't speak Italian, right? So the exclusion criteria might be, maybe the study was conducted in another language we cannot speak, or maybe we don't have full text for it, right? So exclusion criteria removes individuals or studies that otherwise have met the inclusion criteria, that for whatever reason, we cannot include them in the study for whatever reason, like we said. Your inclusion criteria and the exclusion criteria have to be well-defined in your protocol so that you're not just changing the criteria as you go, right? Everything has to be defined a priori, and you have to make sure that you adhere to those criteria and do the study per protocol. You want to make sure that you search at least 2 databases. It is ridiculous if you come and tell us that you've done a systematic review that was based on just 1 database. It's like, no, that is not a comprehensive review, right? So you cannot just use PubMed and say, oh, we've done our systematic review, and as a reviewer, if I read that, I'm like, no, this is not a comprehensive review. You use only 1 database. So you have to make sure that you use at least 2 databases. Cochrane recommends that you use PubMed and Medline, Embase, and the central database for at a minimum for searching, right? More should be searched. Again, it depends on the context. You can use others so that you get a good flavor of all of the evidence that exists. If you are in an institution where you have library support, you can request for your librarian to help you with the literature search. Then the gray literature, that is also a very, it's very important source of data. The gray literature is often more current than the published literature. It takes, in some cases, 1 year, 2 years to publish a paper. Well, the gray literature is current because it doesn't undergo that extensive, peer review process. And examples of this could include dissertations. We have hundreds of thousands of doctoral students around the world, and some of them doing great research on very important topics. This evidence is obviously not peer reviewed, but ends up in dissertations or databases for dissertations in their universities. This is part of the gray literature that will be so important when you are doing a literature review. You also have conference abstracts or papers which do not undergo peer review, but are important. Government agencies like the FDA or CDC or NIH also do research. And so the evidence from that will also be, included. And then clinical trials. These are ongoing or unpublished evidence. These are also part of a gray literature that could be considered to be for inclusion. And then additional searching tips include hand searching. Hand searching means, it's possible that you did not capture every single thing from your review of those databases. So you could go and, like, if I'm doing work in tobacco control, I could go to the top journals in that field and just manually search and make sure that I do not exclude any evidence. You can also do some hand searching by speaking with experts in the field who know the literature in and out, and they could help you know or alert you to what studies you might have excluded. But again, remember, the goal of systematic reviews and meta-analysis is to capture every single study that meets the inclusion or exclusion criteria. So that is why you have to go to such extent, because if you search only one database, how did you know that you've not excluded studies? So that is why we search multiple databases, and that's why we go through extraordinary measures to ascertain that we are including every single thing. It is extremely important to keep good records when you are doing a literature search, and that includes every single thing from what databases you used. Please do not rely on memory. 2 months from now, 3 months from now, you will forget what you even did. So make sure you keep good notes. Make sure that those notes are standardized and are accessible to all members of the team. And so what you want to capture include a list of databases, the limits of a search, like what date ranges did we use, what were the search terms, what languages did we include, or what languages did we exclude, as the case might be. The exact search terms has to be included. So when you're putting a search term in PubMed, make sure that you save each search term. Next week, we're going to focus exclusively on searching PubMed. So we're going to talk about all issues related to searching databases next week, right? But you want to really make sure that you document all of those things. And so documentation, we cannot emphasize it enough for why it's so important in systematic reviews. You cannot do a systematic review with one person. That is not a systematic review. There has to be at least 2 members of the team. And so you have to also have to document how are we going to resolve conflicts. That has to be documented beforehand, right? So you can say if there are conflicts, perhaps we can reconcile. The second person can review and see if they can agree. If the 2 cannot still agree, maybe we'll have a third person who will serve as a tiebreaker. That should be documented. It's not that when you now have disputes, that's when you now start fighting. All of this should be documented beforehand and you do it clearly. You should also calibrate all the members of the team. Calibration is what we do to ensure that each person is standardized and we're not capturing noise. So it means that if Mr. A did a review and Mr. B did that same review, they'll get the same thing. And so generally, you typically want to calculate a kappa statistic that will measure agreements between the reviewers. There are so many software for managing references that don't have to go over that. EndNote, Mendeley's, Zotero, and so on and so forth. So screening articles, you start from the very top. You look at the title. Sometimes just the title is enough to tell you that this is not a good fit. If our study is looking at smoking and lung cancer, if the title is talking about alcohol use and colon cancer. Just looking at the title tells you that that's not relevant. And so if it's not relevant by title, we then screen the abstract. And then if that passes that criteria, then we can go on to review the full text to see the fits with our protocol. You want to create a form. You cannot do a systematic review without having a data collection tool or form to use. And the tool you use is, I mean, it doesn't really matter what tool you use, but you want to make sure that one, it's collaborative. Remember that you must have at least 2 reviewers on a systematic review. So you want to make sure you use a collaborative tool. You want to make sure that you are all measuring the same things, right? And that's why you want to have some training of the reviewers beforehand, so that everybody understands the criteria, so that you're not comparing apples to oranges. Everybody understands that this field means this, and when they're extracting the data, they're actually capturing that exact same thing. And so again, documentation. It has to be transparent, right? There has to be transparency in how we do things. If we select certain things or we define things a certain way, we need to justify why we did it that way, so that there's transparency and it's reproducible as well. We've talked about the flow. Again, this has to be documented. All of this, I'm just trying to emphasize the importance of documentation in systematic reviews. You don't just search and save your results without clearly documenting how or what happened at each stage of the search. Data extraction fields. This, yeah, a ton of things. This is where you want to spend a lot of your time to decide as a team what you want to extract. And again, this is why it's important to use the PICO framework. You define population, the intervention. See, all of the elements of PICOT have to be clearly represented. So, for example, P in PICOT is population. What are we going to capture on a population? Each of these will be different fields. What are we going to capture in intervention? And the control group, right? What are we going to capture under the outcomes? What the issues of time and the study design, right? How are we going to capture all of those things? The bias from the study designs. So using the PICOT framework allows you to be able to design your questionnaire or your data collection tool so that you don't miss any single thing. So these are just some of the elements that you want to make sure that you capture. And we're going to show how, how we can set up that data collection tool so that we capture all of these elements that we need for our study. So screening. After screening, you want to make sure you critically appraise the evidence, right? So you've set up your tool, you've collected the data. You want to make sure that all of the studies included are fit for use and fit for purpose, right? And so that means that you want to make sure that are we capturing the right thing, right? The outcomes we've captured, or each of the studies that we included, how was the quality of the evidence from them? What outcome measure was used? Again, this is very important. What outcome measure was used? Do we have to standardize it to another outcome measure? So, for example, if they use relative risks, or if they use odds ratios, do we have to standardize it to relative risks? Do they use risk differences? Do we have to standardize it to something else? You can't just do the data extraction blindly, right? You need to know those fundamentals so that you're not comparing apples to oranges. And so another very important thing is the risk of bias, right? From each study. You need to review each study. It's not just grabbing the results from each study, but also reviewing issues of bias that might come from each study. Again, bias, we want to look at it from the perspective of both internal validity and external validity. So internal validity was, did they control for confounders, right? What was the extent of selection bias in the study? What was the extent of missing values, right? Which could also be an issue of selection bias, right? And also issues of generalizability. So in general, the 4 sources of bias that you really want to worry about when you're trying to appraise the quality of data are selection bias, right? Performance bias, attrition bias. Attrition bias means that maybe the 2 groups, people left the study differentially, right? Why did you do that? And then, ascertainment bias or detection bias that could creep in from how things were measured. These are different checklists. We're going to share these slides with you. So You can review some of these checklists to see which one will be appropriate for you. There are checklists for clinical trials, there are checklists for non-randomized trials, and many others. And so the goal is for you to be able to use the relevant tool to find out, appraise the evidence from the study. And so that is the end of our presentation. I would like to now show you quickly how you can set up your data collection for your data extraction based on the parameters that we have set up, which are these ones here. Again, there are many tools that exist out there, but when selecting a tool, you want to make sure that you select a tool that allows you to work collaboratively and where you can capture all these details in the different formats. So I wanted to do two things after this presentation. One was to show you a quick, example of how you can set up data collection on the Chisquares platform for your extraction. And the second one was how you could create a forest plot, like this plot we saw here. Let's see. Like this one here with just Excel. This is something you can do very easily in Excel. And so let's see how much time we have. We'll take one. If we cannot finish the second one, we can just push it to next week and do that accordingly. So for now, let's just show you how you can set up your data collection tool on the Chisquares platform to extract data for your studies. So to access the Chisquares platform, and for those of you who are not familiar with the Chisquares platform, it's a research platform. It's designed to be a one-stop shop for everything research, right? So in a systematic review, for example, we talked about appraising the quality of the evidence, and that includes sample size calculation. Was there adequate sample size in that study, right? The study concluded that there was no effect. Is it truly that there was no effect, or was it that the study was simply underpowered? So the Chisquares platform allows you to have one comprehensive one-stop shop where you can assess those various aspects of quality. So I'll just quickly walk you through some of those aspects so you can see how to use them when you're doing your systematic review, and also how you can set up your data extraction tool on the platform as well. So you log in if you have an account. And so here you will see the different components of a platform. The ones that are most relevant for you when doing a systematic review will be the sample size that allows you to be able to determine whether the sample size used in the study was adequate. Again, as part of quality appraisal, you want to make sure that everything that the reviewers or the study concluded was actually accurate. So if they said that there was no difference detected between the intervention or the exposed and non-exposed, is that true? Or was it because of poor sample size or small sample sizes? The only way you can know that is to appraise that, so in that case, for example, we can come here to the study type that they had. So let's say that they did a prospective or a retrospective cohort study, and the baseline, the prevalence of the outcome among the non-exposed group was, let's say 30, and the prevalence among the exposed was, let's say 20, and the level of confidence was this. The test was two-sided according to them, and the ratio of exposed to non-exposed was this. How many people do we need for that study, right? So that is what the tool will help you to achieve. So you can calculate the sample size, and you know that, okay, we need 2,628 people in the entire study. But when you go back to the original study, you found that, they only had 500 people per arm instead of 1,314 people per arm. Well, that suggests to you that, well, this claim that there was no difference between the two arms could be because there was inadequate power to detect differences between the two groups, right? So you can use the sample size tool as part of quality assurance. Remember, we said that when you are reviewing the quality of the evidence, you want to look at issues of bias, including both threats to internal validity and threats to external validity as well. Now, you can also use the survey design part to design your data collection tool. And let's quickly set it up how we might do it that way. should we want to set it up like, on the platform. So here you set up the title of your systematic review. So here, for example, if a systematic review is this one, for example, let me just copy this title. If that's the title of a systematic review, we can simply copy that and include that in the title. The location of our participants, if we know that, we can include. But again, systematic review, we might not necessarily know where the evidence is coming from, so we can leave that blank. The aims of our study, if we know the aims, we can type them. If we don't, if we're just trying to write a protocol, we can ask AI to generate the aims for us. And so that we provide the aims that will be used for the study in terms of a systematic review. So I'm just going to select 2 random ones here. And then the keywords. The keywords could be, again, based on what the research question is. Let's say index case or European region. And then we don't need ethical review for systematic review because we are dealing with non-human subject research. So based on that, we can create our projects. Now, you cannot have a systematic review done by just one person. That's not a systematic review. You need to have at least a team of 2 people or more. So this is where you enter the emails of your collaborators. So if my collaborator is this, and again, this allows all of you to be able to work together in real time in a way that is transparent so that you can see what the members of your team are doing in real time. So you provide an email and you assign them a role, for example, co-lead or project owner. You can add as many collaborators as you want to the project. And once you do that, you can save so that they are invited to come to the project and participate. So now we've set up our systematic review of outbreaks of COVID-19 within households when the child is the index case. So now we can now start creating questions that would map to the fields we want. So here, for example, we'll start with a blank survey and we'll set the questions we want. So let's say our first field is the study ID. So the idea is to create all of these fields into our survey so that everybody has access to it. It's systematic. You can access it from everywhere, and all the data from the different collaborators are collected in one place. So we have a study ID or reference number. So we can come here and create that. So come to open-ended questions, and you can say study ID. So let's give that a label. And we can look at how it's going to look. Study ID, then the user can enter the value. So push that to questionnaire. If we want to make everything required so that people do not just skip the field, because one of the problems is when you're doing a systematic review and some collaborators are more careful than others, some might mistakenly omit some fields. So we can click on make required so that everybody has to provide that value before they proceed. And then we can provide the next fields like the study title, the year of publication, or the date of publication. Let me create that quickly. We'll come here, open-ended questions, and we can select the date. So we can say date of publication. So we want to know the precise date of publication. So let's select the settings, and let's say we want just dates only. I want to select the format. Is it month, day, year, or day, month, year? Whichever format we want, we can select that. If it's it depends on the field or the part of the world different parts of the world use different formats. So you can select which one you are sure that most of the papers might report. And so, but regardless of the issue, you can once you select the format you want, you can then apply that, and so that you have that field created. Let's call this dates. Let's call this publication dates. Publication or just simply dates. And we can now push the questionnaire, right? So that's how we'll do that for the different fields. You want to make sure that you ensure there is very little risk of collecting poor quality data, right? So for certain things, you might want to make sure that so for example, let's say we are trying to look at a field like, let's say sample size, right? You want to make sure that people don't mistakenly put alphanumeric characters. Sample size should only be numbers. So in that case, I'll make sure that I'll create a question, like an open-ended question, but make sure that it only allows numeric values. So sample size, come here, I'll say allow only numbers. So that way, people don't mistakenly type in letters. Because one of the problems with systematic reviews is that you have a large team all entering data, and then you end up with very, very poorly collected data because people are entering different things that do not make sense. And then you have to now start cleaning the data. So it's better that from the very start, you set up the data collection tool in such a way that there is no probability of that happening. So let's call this sample size, and we push the questionnaire, and so on and so forth, right? Those are some of the things we can, then you have things like dosage. When you are creating those kind of questions, you want to make sure that you consider things like units of measurement. People might, let's say the research question is about cigarette smoking. Collect the data in such a way that it allows you to capture units of measurement in a very fine way. So for example, let's create that to illustrate what we're saying. So let's call this so let's say effect size, right? Effect size measured from study. So effect size, like we said earlier, could be in odds ratios, risk ratios, hazard ratio. So it's not enough for you to create a column for effect size and not put units of measurement. How then are you going to standardize it? This is a problem I've seen time and time again. You see people collecting their data collection sheets. They'll just say effect size. Like, okay, how are you going to know that what was measured was a risk ratio versus an odds ratio? And if you don't know, how are you going to standardize at the end of the day? So it's very important that when you collect certain things, you should automatically know that you need to collect data on the units of measurement as well. So for example, here, effect size measured in study, I would come here and say, first of all, allow only numbers, and then provide units of measurement. So the units of measurement could be, for example, odds ratios, OR. I could put things like risk ratios. I could put things like risk difference, and so on and so forth, right? I'm not going to put all of them, but just to illustrate what we're saying. And we might want to also provide, are there minimum values, are there maximum? Again, that depends on the context. And once we're done, we apply. So that allows us to make sure that when we look at the question, effect size measured, the user provides a value, and then they provide the unit of measurement, whether it was odds ratios or risk ratios. This is so important because it allows us to make sure that at the end of the day, we can be able to standardize our measure. We cannot standardize if you do not collect the unit of measurement. Like, how are we going to know that? So this is extremely important. And then we can push to a questionnaire, right? So this is how you go about creating all of those things. For certain things like, open-ended things, you want to make sure that just comments. You want to make sure that you provide open-ended comments for folks to provide the value. So for example, we can just say, let's add an open-ended question, like multi-line question, comments about overall bias or whatever it is we're trying to capture. So this way, every member of a team can then provide, their entry in open text there. So that when you are now collecting the data as a team, you come here and let's go to settings. You make sure that you allow for multiple entries so that as you fill one study, you can continue with the next one. So you allow multiple submissions and we can save. We can also allow to see the results of what we've entered so that we can make changes if necessary, and we can save that. so that when we now are doing our review, let's look at a preview of how that looks like. We can then we can now start entering the values that correspond to that. So study ID, we provide the ID of the study as necessary. The date of publication, we select the date, whatever, 2024, this is according to the format we selected. The sample size, we selected so that this is only allows numbers. So here, I'm actually trying to enter letters or alphanumeric characters. I can't because I specified that I only wanted numbers only. So we'll provide a sample size. And then later on, with your quality assurance, you can actually assess to see whether the sample size reported from the study is actually sufficient, right? This is all part of quality assurance. And then the effect size measured, let's say we had an odds ratio of this, and then we'll provide the units of measurement as, risk ratios. And so that allows us to, capture that clearly. Comments about overall bias, provide that, and then we submit, right? And then we can see what we entered. If necessary, we can make corrections to it accordingly. So that's how you can set up your data collection but you want to make sure that you are very comprehensive in capturing all of these values or all of the data. Make sure that you and the team discuss upfront and a priori, and all the necessary fields are captured, so that it is not when you are like 200 studies in, you'd realize that, oops, we forgot to capture this field. Now you have to go back and start all over again. So clear communication between members of a systematic review team is extremely important to make sure that everything is done comprehensively and in terms of high quality. I'm going to stop here. Next week, we will just have to push this, the creation of this figure we talked about, to next week. So we'll show about how we can, so next week is focused on how more of hands-on in terms of like some of the visualizations that we talked about, and more of hands-on on some of the various aspects of what we discussed today. Today was meant to be just very high-level overview of the different types of reviews that exist, their differences, and their relative strengths and weaknesses, so that we're all on the same page as to what these things are. So I'm going to stop here and see if there are any questions.
Thank you, Dr. Agaku. Dear participants, please do not share your email addresses. I have just posted a link where you would then provide your email address and your name so that we can send you a certificate. So kindly stop sharing your email addresses. Use the link that I just posted. I'm going to post it again. There it is. Please provide your details there. You are not forced to provide feedback, but if you would like to receive a certificate, please provide your name and email address. We would like to hear what your thoughts, and let us know how we can improve, but you are not forced to do that. So, Dr. Agaku, there's a question. Is it possible to exclude a study you could assess the main text despite it meets all the inclusion criteria?
So let me make sure I understand the question. The study meets the inclusion criteria, but you just could not get the PDF. So you want to remove it. Is that what your question is about? If that's the question, no, you cannot. And so your job at that point is to hunt down those authors, if you can, and get that PDF from them. You should try over and over and over, because if you start just systematically removing papers just because you don't have access to the PDF, you can see how there's a risk of bias being introduced. It means that your study is just capturing evidence from only open access studies. So please don't do that. If you can't access the PDF, ask a friend who is an institution that has access to provide it for you, right? But by all means, try and get it where possible.
Okay, I'll let someone ask a question, and then I'll verbally, and then I'll get back to the chat box. Ishmael.
Okay, thank you. My question is on the difference between text review and narrative review. Are they really the same or they are different? Thank you.
What was the first word you used? Narrative review versus, I didn't hear you clearly for the first contrast you mentioned.
Oh, sorry. Ishmael?
On mute. Narrative review versus text review. Text review.
So so different fields might use different terms, but narrative review essentially means that in a nutshell, you are using summaries, right? You're just summarizing the data. In that, think of a classic, review of your text of a narrative review as the common literature review. When people say literature review, what they're literally referring to is a narrative review, right? And so that is what we mean. So the opposite of a narrative review will just be, a more systematic or quantitative review, where we are either, summarizing the data quantitatively. For example, in the case of a meta-analysis with a single quantitative summary, right? So there are a whole bunch of terms that people use to describe the same thing, but you want to understand it fundamentally in that context, that if it's not a narrative review that you're doing, then you might want to summarize the result as a table, right, in a tabular form, or you might want to summarize as a visual as a figure, or, in the case of more quantitative analysis, you might want to summarize it mathematically or statistically with a summary estimate that summarizes all of the data. So they, regardless of whether it's potato in terms of whatever nomenclature is used, those are the fundamental things you really want to be cognizant of.
Thank you so much for the insightful explanation. I would like you to explain if the data entry can be performed offline on the Chisquares website.
Yeah, you can perform it offline.
Okay. Okay, Rike, promise.
Thank you so much. I would also
promise you may speak.
Can you hear me? Hello?
Okay,
Yeah, we can
you
hear
can
you.
go ahead.
Hello, can you hear me? Hello?
Yes, we can hear you.
Okay. So thank you very much, Professor Gaku. I'm
Is it just me or has he gone offline?
Okay, I think he's gone offline.
Okay.
Prof. Hamidu?
sorry, I was muted. I was muted.
Okay.
Okay, sorry. So as I was saying, I just have a couple of questions. Number one is how do you get the risk ratios and all ratios from papers to be able to calculate their effect size? Then number two, can the chi-square help with developing a protocol for a systematic review or even a scoping review, as the case may be? Then, for example, I want to conduct a systematic review, and most of the things that I'm seeing are just case reports, because the field is there is a dearth of data in that particular field. So, what is the recommendation or advice that you're going to be given in such an instance? And then finally, I want to write a narrative review or a short communication, but because of the fact that the topic or the field I'm working on is still emerging, is an emerging field. How do I approach this scenario? Because, for example, the field of high function depression is very much still emerging, and it's kind of there's nothing much anybody can do about that. So how do I approach this particular problem? Thank you very much, sir.
Okay, so the first question, your question was, how do you extract odds ratios from studies to calculate the effect size or the effect? Well, the odds ratios are the effects. So if you extract them in the study, then you don't have to calculate it. We're talking about the same thing, right? So the effect is the odds ratio, right? So, and how do you extract it? Well, you have to read the study. So you read the study, and this they will tell you that in the main effects, the association between smoking and lung cancer, was calculated to the odds ratio of 2.50, right? With confidence intervals of so and so. That's the value you're going to extract and use for the report. One of the tools we're in the process of building is a tool that will allow you to be able to do all of its data extractions automatically. But that's still light years ahead, because systematic reviews, obviously, as you're aware, is pretty complicated, and it's something we have to make sure we're 100% accurate in terms of the data and the processing and the engineering. And so, but that's something that we have. But for now, you just have to read the paper. Even if you have an AI tool that assists you, you want to make sure that you verify and you validate the extraction that was done. So I hope that is clear. So again, the effect is the odds ratio. So it's not as if you extract the odds ratios and then calculate the effect. However, like I said earlier, you might need to standardize it. Like studies might have odds ratios, or others might have risk differences. You cannot compare apples to oranges. It doesn't. That is just junk science. You will have to standardize them. And like I mentioned, I will share with you a tool we built that is a quick Excel tool that you can just quickly convert from one to the other, should you need to do so. Your other question was about, sorry, I took notes of the question. Let me refer to it. Okay, you have an emerging field. There's very little studies done. How do you do a systematic review? Well, if there's very little studies done, then that means that what you need to do might not be a systematic review after all. You might want to you only do a systematic review if there are enough, if there are enough original studies. And again, remember that the main question, or the main need for a systematic review, is when we have equipoise, when we are not even sure what the direction is. If you don't have enough studies, it's like, well, there's no studies. So what you should be doing is original studies that would answer specific questions in that field. So that might be an indication to you that what you need now is not systematic reviews, but more of original studies. And if you don't know, you can also write opinions, right? Opinion, like, okay, as a researcher, this is my opinion on this issue, but systematic reviews, you can only do them when you have studies, primary studies that were conducted. So that is that. Then the last question you asked was about whether Chisquares can assist with protocols. So yes, we are releasing the tool in exactly 19 days as part of our AI toolkit that will allow you to write proposals or protocols in seconds, right? For whatever study design you're doing. So you should definitely be on the lookout for that. We're having a release of that tool in 3 weeks, roughly, from now. So that would allow you to do all of that in just literally seconds. But of course, the expectation is that you can then pick that up and then review it and make edits. It's easier for you to, it's easier for people to generally edit things than to build from scratch. So the whole idea is that we empower researchers to create those kind of things in seconds to minutes, and so that they can then make changes as needed. So I think I answered all your questions. But if I omitted any, please, you can bring it back, and I'll be happy to answer it.
All right, I'll take one from the chat box. Are bibliometric reviews considered as rapid reviews?
The type of review is not necessarily based on, it is based on the scope, the urgency, the resources, and the comprehensiveness. So it could be any of those things, depending on how, like, did we do it comprehensively, right? So it's not so much about the issue of nomenclature, but how it was done. So it's all about context.
Thanks. Prof. Abdul. Prof. Hamidu. Please unmute yourself.
No. Welcome.
Okay.
Good evening, sir.
Okay.
Hello. Okay. Am I
Prof.
audible?
Hamidu, please. Okay.
Yeah. Am I audible now? Yeah. Thank you. Prof, well done. Yeah. My question is, for example, when you want to assess United Nations World Health Organization intervention in terms of maybe monkeypox. So in that case, do you have to use the picotis or what? And is systematic review and other systematic review common in the humanities or not? And then is the picotis also very common in the humanities? Can we use it all or in our research questions? And especially development studies. Thank you, sir.
Yeah, you can use the Piper framework anywhere. It's agnostic of discipline, right? So it's agnostic of whatever discipline. So whether your research, for example, your research question could be, what is the association between receipt of foreign aid and poor economic indicators in a country? Let's say Nigeria. That's issue of development, right? But it's still applicable. In this case, your population is Nigeria, your intervention is foreign aid, your control is not having foreign aid, the outcome is poor educational indicators. The study design is whatever design you want to do, right? So it's agnostic of discipline. You can apply it in any context, including the social sciences. And yes, you can also apply systematic review in the social sciences. These things are agnostic of your discipline. So it's not tied to one discipline. So it's all about the context. Context matters. So in your context, for example, maybe you don't have a lot of studies or there are no studies at all, in which case you can't do a systematic review. But in terms of the issue of discipline itself, that is immaterial.
Thank you. I'll take another one from the chat box. Where do we place scoping reviews?
In terms of what? So we provided a framework here earlier that provides you with a framework in terms of how you want to think about them, right? So here, let's see, right here. So again, we say we have three major buckets. One is when we have a specific predefined question. Second is when we have broad and more exploratory aim. And third is one with there's actually not a question, we just want to see the lay of the land. And so here you can have either a mapping or a scoping review depending on the breadth of the question, right? But again, I would encourage you to focus less on just classifications or categorizations of things, because this could vary from subject to subject or from discipline to discipline, and to worry more about what is the methodology, right? What is the risk of bias, right? How do we assess it? Is there an appraisal, a critical appraisal of the evidence? And how do we mitigate that if possible? Can we do, if possible, right? Can we do a more robust design than a less robust one? Like, why are we choosing to do a quick and dirty review, a rapid review? Why can't we do a systematic review? So if, for example, you're even supervising a student, let's say you have a master's or PhD student that comes and says, oh, I want to do a mapping review. It's like, why, right? It's not just, oh, let's go and do it. It's like, what is your justification for wanting to do this? Why are you using the least rigorous approach to do X, Y, and Z? Why can't you have to convince me that there are real legitimate reasons why you cannot do, a more robust design, because obviously that one takes less effort, takes less time, takes less stress, takes less, intellectual commitment. So those will be more, greater or more pressing concerns from a design perspective. Just ensuring that as much as possible, we go up the ladder in terms of rigor.
Thank you. Margaret, okay.
Good evening, Prof. Thank you very much for the lecture. My question is on the reviews. Is there a review called an expert review? Is it a different type of review? I want to know, what is an expert review?
So, as the name implies, it's an expert, it's an opinion, right? An expert review is, it could be that there are different ways you can think of it, right? If it's just one expert, if just one guy giving his review of an issue, that could be an expert opinion. Or it could be a panel of experts who come together and say, oh yeah, based on this, we've agreed that so and so, this is now a consensus report, right? It's just experts saying, oh yeah, we think that this is the case and we agree. Consensus simply means we agree. However, in terms of evidence ranking, that will fall at the very, very bottom. Why? Because it's just people's opinions, right? Your opinion doesn't make up for science. So again, like I said earlier, where possible, we really want to justify why we do certain things. Like, why are we doing an expert review? Like, is it that there's no evidence? So you can use an expert review or expert opinion, or when you don't have real data and you're like, okay, well, let's see what the experts think. But they're just guessing, really. Experts just guess all the time. So where possible, right, we really want to make sure that we go for up the ladder of rigor, right? If possible, like, why are we doing expert opinions or consensus when we can do something more rigorous, like a systematic review or a meta-analysis? So we never want to substitute anybody's opinion, it doesn't matter who it is, for actual empirical evidence.
Thank you. Oopsie. Okay. Do you pull studies that employed similar study designs or different study designs?
It can be different. You can pull studies, but obviously, when I mean different, in the context of the research question, if you are looking at, let's say, the research question we've been playing with, the relationship between, let's say, smoking and lung cancer, obviously, that's an analytical study. You can't be bringing in a cross-sectional study or a case report. But in the context of that broad umbrella, you can include, case control studies. You can include cohort studies. And so that is allowed, right? So yeah, you can pull it, and that is why I was emphasizing earlier that you need absolutely to be able to know how to convert one measure of association to another, because a case, a conditional logistic regression from a case control study will report odds ratios. A cohort study will report relative risks. So if you're pulling data from a case control study and a cohort study and a clinical trial, obviously they will all report different measures of association. They are not directly comparable. You got to standardize them first. So I cannot emphasize that enough. So that's why we went through all of this to indicate that, yes, you have to compare apples to apples. You cannot compare apples to oranges.
Thank you. I needed some more explanation about PRISM.
Well, we'll provide links. It's just a framework to guide you on how. So there are different frameworks that guide how we do research and how we report such research, right? And there are many of them. We have for observational studies, for example, we have STROBE. STROBE stands for Strengthening the Reporting of Observational Studies in Epidemiology, right? For clinical trials, we have a different one. For meta-analysis, we have different ones, right? They are like checklists. It's checklists that says, when you're reporting this, make sure that you do this. Make sure that this is present and that is present and that is present. So that is what those checklists are. And it's just to make sure that we are all doing the same thing. We're all reporting research in a way that is standardized and directly comparable. So that's how you want to understand it. So it depends on the study you're doing. You want to make sure that you're looking at the right checklist. So we've provided links to the different frameworks that you want to use. I think it's somewhere down the screen. So I won't share the screens, the slides. You want to make sure that just take some time and read through the different checklists. I think I have a checklist for one of them open. Let me see if I can if I do indeed. Maybe not, but again, we're going to share the screens, and so you want to, again, they're just checklists. Make sure that this is there, and that is there, and that is there, and that you report it this way. So that's essentially what they are.
Okay. Ogochukwu.
Okay, thank you very much, Prof. Please, just to confirm, I don't know if I got you right when you were trying to differentiate exclusion criteria from inclusion criteria. Well, I think I heard that exclusion criteria are part of the inclusion criteria that didn't meet the requirements. Giving an example of maybe a study that was not done in English. So now, if I'm doing a study, a systematic review on maybe a particular topic on the children in Africa, my inclusion criteria are children studies that are done in Africa among the children. So assuming there's a study that is conducted in Africa among children, but not reported in English. So this language has excluded it. Is that, I don't know whether that was what you were trying to explain about exclusion criteria. Please, can you throw more light, sir?
Sure, I'm happy to do so. So inclusion criteria. So what I was discouraging you from doing is to have an understanding that, because this is a very common misconception where people interpret inclusion and exclusion criteria as though they were just mirror images of each other. That is wrong. So inclusion criteria is like we put our arms and say everybody in here is included. So going back to your own analogy, your study is looking at issues. Sorry, I've forgotten the research question, but your study is looking at issues of malnutrition among children in Africa. Now, there's no rule that says this. You can choose to say the inclusion criteria are studies done among children aged under 5 years old or whatever the age is. Studies done in Africa, studies in which the outcome of interest was malnutrition, right? Those could be the inclusion criteria. So these are the studies that fall within this cycle now. So any study that doesn't meet those criteria is outside this cycle. Now, among those studies that otherwise have met the inclusion criteria, you now say, oh, okay, but even if you met all those criteria, but you were written in Chinese, well, you will be excluded, even though you met the inclusion criteria.
Okay.
Do you understand?
Yeah.
So exclusion criteria is not a mirror image of the inclusion. They are very different things. This defines the inclusion criteria. The guys in red do not meet the inclusion criteria. The guys with the question mark do not meet the exclusion criteria.
Okay.
Do you understand?
Yes, Prof.
All right, great.
Thank you.
You're welcome.
Please, can you kindly repeat how you started the review process in the Chisquares platform?
So I want to make sure I'm answering the right question. Are you saying I should repeat how I started the setup for the data collection? Because that's just one small part of a review. Is that what you're referring to?
Endoro, please respond. In the meantime, let me give Joshua Douglas a chance to ask a question. Joshua?
All right, thank you.
Okay. How about Toyosi, Rahim?
Can you hear me? Yeah, okay. Thank you very much, Prof. It's been very interesting listening to you. I'm Toyosi Rahim. I work at Nigerian Institute of Medical Research in Lagos, Nigeria. Please, I have two questions.
Okay.
The first question is the use of a collaborative tool. And if one has a postgraduate student, for instance, a PhD student, that is to do a scoping review or systematic review before the main study, will you advise that the person to use collaborative tools? Because sometimes the examiners will ask the student, is it your work? If it is your work, why are you collaborating with others to present these findings? That's the first question. Then the second question is still on collaborative tool, but I want to find out the use of RAIAN. Is it possible to use a chi-square platform in place of RAIAN to get the same result? Thank you. Over.
Thank you. So I'll answer the second question first. These sessions are not about endorsing one software over the other. So you can use whatever tool. We're more interested in ensuring that we pass out the fundamental knowledge of what we're trying, whatever it is we're discussing. So if it's one tool you're familiar with that works for you, oh, absolutely, you should continue using that, right? If you're more familiar or more comfortable with the Chi-Squares platform, by all means do. But the goal again is not to market one tool over the other. So just to emphasize that. Then going to the first question about collaborative tools, even if let's say you have a student that has to show independent work, it's great. If I were a supervisor, I would want to know what the student is doing. I would want to, intermittently check in on their work, so that I don't want them to go a long way, like 3 months later, and then like, oh, you did the completely wrong stuff. Having me as a supervisor on their project allows me to, once in a while, just check and say, okay, is this person going on the right track? Or do we need to completely make a U-turn? So the usefulness of collaborative tools cannot be overemphasized. Like, it helps with quality assurance. It helps with providing support in real time. It's a two-way thing. The student doesn't have to email you things before you can provide feedback, right? You are already on the platform. You can see everything that's happening. So it reduces unnecessary communication via email. So it reduces the extra work for the student to start sending you things or scheduling meetings just to give you an update. Well, you can see it yourself in real time. Like, what do you need an update for? Except if they have to present the research to you, but you can provide feedback in real time. And then for you too, you can also provide feedback to them in real time, so that way it's seamless. And then collaboration also doesn't mean the role of collaboration in research today cannot be overemphasized, because it's rarely now does any one person do research, because even if they're working for their PhD or their master's, most likely they're in many settings, at least, it's still a collaborative work where the student is just in charge of one small part of a bigger piece of work, right? A PI might have won an R01 grant. That is a huge grant. And many students are getting their PhDs or their degrees from that one large grant. Independence doesn't mean that the student is the one overseeing every single thing. It just means that they're in charge of one small part of the grant. And so we still need to work collaboratively. So any day, anytime, I will always emphasize the role of collaborative tools, especially in the context of supervision, because if I'm supervising a student, I really want to know what's happening in real time, and provide feedback in real time. And I don't want to be spammed via email. So the best way for me personally is to make sure that we're on the same collaborative platform.
Thanks,
Okay,
Dr.
I hope that's clear. All right, next question, Umile.
Can exclusion of language cause bias?
Yes. So
What
go ahead, sorry.
No, sorry, I thought you were done.
Okay, well, you forced me to be done, so I'm done.
What criteria is used to determine the eligibility of studies to be included in your systematic review?
The research question. You, the investigator, it's your research. You are the one who has the research. So you are the one who will be telling us, the readers, that this is the inclusion criteria, this is the eligibility criteria. Nobody knows that except you. Why? Because you are the one who came up with the research question. So that is driven by the researcher, and you now frame it with PICO or PICOTs, as the case might be.
Okay, let's go back to the hands. Ola Sunkanmi, Ridwan. Ola Sunkanmi.
You have completely butchered that name, I assure you.
Even the owner can tell. Okay, I'll move to the next one.
It's like, is that me?
Okay, Junaidu.
Hello, good evening.
Hello.
Yeah, good evening. Sorry, I want to ask a question. Can I go ahead?
Please do. Please do.
Please, I'm working on a systematic review of the prevalence of some.
You're cutting out really badly.
Sir?
It's because he cheated the system.
You're cutting out really badly. You're going in and out.
Oh.
Maybe you want to type your question as a chat, perhaps.
Oh, okay. Because I'm driving. That's the problem. Okay. Maybe.
Okay. Ala, you had your hand up for a long time. Ala? Your hand has been up for a while now.
Okay, hello, and
Hello.
thank you for this opportunity.
Maybe I will.
Okay, my question is, what is the number of previous studies I should write in the systemic review? And there is difference between the research paper and thesis. I mean, like the number of previous studies I should write. Okay, and thank you.
I just want to make sure I understand you correctly. Your first question was what is the minimum number of studies you can include in a systematic review?
Yeah, exactly.
Okay, and the second was, what's the difference between the research paper and a thesis? Is that what you asked?
Yeah, the difference between the research paper and thesis, I should write the previous studies.
Okay.
I mean, like there is no specific number in the research paper I should write, and there is a specific number in the thesis, or the same.
Okay. Okay. So there's no set number for the number of papers that have to be included in a systematic review. That would depend on the inclusion criteria and all the other parameters. So your PICO will determine how many studies will be there, right? It's just based on how many you have available. So you don't do a systematic review and you say, I'm going to do a sample size calculation for how many studies have to be included. Sample size calculation does not apply to systematic reviews. It depends, what you have is what you have. So if there are 3 studies that meet the criteria, well, that's what the studies you have. So the number of studies is a function of your PICO framework, your inclusion criteria, and the remaining elements of PICO. Then the second question you asked, which was, is there a difference in what I think I understand what you were asking. Like, is there a difference in what you should report in your thesis versus in the research paper? There's no difference. If you wrote a thesis, the byproduct of your thesis is just a research paper. So ideally, hopefully, the paper should reflect what you had in your thesis. So there's no distinction per se, if that is what you were asking. If that is not, you can clarify.
Okay, thank you.
All right, great.
Thank you very
Must
much.
a research question start with what, how, or do?
Those are not really important things. You can start your research question in however way, but it has to end in the question. I can say, what is the association between cigarette smoking and lung cancer? Or I can start with, does does being a cigarette smoker increase your risk for lung cancer? Or I can say, how is cigarette smoking associated? I can start it in a million ways. So again, we don't want to necessarily fixate on those nuances, because in the grand scheme of things, they're not really important. We just want to focus on like the principles and ensuring that the research question itself, regardless of how we started it, has those elements of PICO and ends with a question mark. So it's not about how it starts, it's about how it ends.
Thanks. Junaidu?
Thank you very much, Prof, for the presentation. My question is regarding rapid review. Is it only conducted during emergency cases? Like in the course of your presentation, you mentioned example COVID-19. Rapid review are usually conducted. So I want more clarification on it.
Okay, it's conducted. So simple answer, no. It's conducted in whatever setting we have, where we have scarcity of resources, but we need some information rapidly, right? As the name involves the rapid review. So if I'm an editor or a reviewer and you submit a rapid review, my first question is why? Or if a student comes to me and says they want to do a rapid review, I'm going to ask them, obviously, why? Why do you want to do a rapid review, which is the worst of the studies in terms of evidence quality, right? Why are you not doing a more robust study? Like, you really have to convince me for the need of that before that study can go on, because, you know, otherwise it's dead on arrival. So the simple answer is no. It depends on the context. So your context might determine that you use it, but you alone know what that context is.
Thank you. How do we decide to choose between a systematic review or a scoping review?
Okay. Those are very, very different in terms of what they are trying to achieve. A systematic review is very methodological, right? Systematic review, you cannot do a systematic review with one person. You need two or more people. You need two or more databases as well to search for a systematic review. But the question is, what if, you know, and we're talking about ideal scenarios, but what if you don't have the time to do search all the, you know, the papers? And again, remember that for a systematic review, we need to include every single study that meets the inclusion criteria. It's not a pick and choose. You got to include everything. But what if you don't have the time to do that? What if you don't have the resources to do that, right? Some of these decisions are forced on you by circumstances, by context, by the time you have, by resources you have. So it's impossible for us to provide one answer that says, this is what you choose. Well, you choose them. You are the investigator, was the one that chose it. So you are the one who should be telling us why you chose it. So it depends on context.
Jonathan?
Thank you very much. We are very grateful for the lecture. I have two questions. One of them is I wanted to ask whether the slides will be shared to us. And number two, I log into the Chi-Square platform and I saw that they have how do you call it? An upgraded form where you can get they have BC standard and professional. I just wanted to ask, should we use the free version for now, or we should upgrade for multiple surveys? I just wanted to ask. Thank you.
Are you in a Nigerian institution? Are you in a university in Nigeria?
No, I'm investing in Ghana.
Okay. Well, Lungile will share a link that will allow you to get access to a premium plan on the platform, so you don't need to make those selections. Regarding your first question, yes, the slides will be shared with the community afterwards.
Okay, we've been sharing the link. Jonathan, please check. If any of my team members are here still, can you also just post again? And thank you so much for your help. Okay, what are the minimum number of studies that qualify as a question for a systematic review?
Okay, I believe we already answered that question. There is no minimum. It depends on the research question and the amount of evidence. But obviously, it should be obvious that if you only have one study, then that's not a systematic review, right? So and then you don't even need to do a systematic review after all, because that assumes that you have multiple studies that meet the the inclusion criteria. So, but there's no minimum that will say, oh, you have to have at least this study. That it depends on the context. And that context is dictated by your PICO, which is population intervention control outcome and time, which is the research question essentially.
Dr. Ada Aquari. You may ask your question.
Okay, good evening, and thank you very much for this very interesting lecture. My own question is, how do I get access to this Chi-Square platform? Because when the tutor was giving his lecture, he did some demonstrations on the Chi-Square, using the Chi-Square, and I would like to have a hands-on practice on that. So how do I get access to it?
Lungile, we've been sharing, the link has been dropped in the chat box. I believe it's going to be dropped again. So you can just click that link and it would provide the access. And let me show this. For those of you who are in Nigerian institutions, you all have access to Chi-Squares platform, whether you know it or not. And this has been sponsored by the National, what they call it, National Universities Commission. So what you do is you go to your institution, you click on that institution, you grab the link for that, and so this is, for example, a university here. Let me agree. You provide your name and your email, and that's how you are onboarded immediately. So the link to this, let me drop the link for this here. Copy this link and drop that here. All right, I think that answers that question.
Thank you very much.
Thank you. Are rapid reviews conducted in emergency cases only?
That question has been answered.
What are the minimum? Okay. Okay. Dr. Emeja Isaac, while I look for other questions. Dr. Emeja Isaac.
Hello, ma.
Okay. Yes, Ola.
Hello, ma.
Yes.
Yes. Thank you very much. I think you just answered the question I wanted to ask, because I noticed RedCap as this Chi-Square app is like RedCap also. I think it has similarities. But I noticed RedCap, you need to have to pay before you access it. So that's the question I want to ask. Is it compulsory apart from Nigerian students? If you are not a Nigerian or a Nigerian student, do you have to pay, or is there something you need to drop before you access it? Thank you.
Yeah, well, everything in life, you have to pay for. There's no free lunch in life. So even if it's free to you, that means somebody else is paying for it. In the case of Nigeria, that sponsorship is done by the National Universities Commission. But we're also trying to provide, support research in other parts of the world. So we are providing our own link for folks to have access to it. But that access obviously cannot be forever. So it ends in April 2025. And after that, you can either use the free plan on the Chi-Squares platform, or your institution subscribes for it, or you subscribe for it. Because obviously for anything to be sustainable, then there has to be a business model behind it. Yes, and the question, yes, those in research institutes not listed, you can go to the bottom of the list, and there is a there's a row there that says school not listed. So you can use that link to get access. And so that is for people who are in Kenya or Cameroon or wherever in the world, or Egypt or Brazil. You can use that last option that says school not listed. Okay. Have we answered all the questions, Lungile?
No, there's still plenty.
Oh, okay.
Please, Prof, could you throw a little light on what informs the choice for a systematic review or a scoping review? What similarity or differences exist between the two?
I believe we've answered that question.
Yeah, sorry, it's been asked repeatedly by different people. Please guide me in the steps for literature review. I have searched for past project work. Seems not to have anything reasonable. How do I gather information for the literature review? This is for a master's project topic, statistical analysis of the impact of stock reporting on stock out rates.
Okay, so if you notice our schedule of events, all of next week is dedicated purely for literature review. So please just come next week. That's the only thing we're covering. So next we're going to cover literature review. How do you do a literature review? And so that's what we're going to cover next week. So please just show up.
Okay, Daniel, you still have a question, Daniel?
Yeah, thank you very much, Prof. As usual, it's been an insightful one. My question goes this way. Can we say that measures or scales like odds ratio, risk difference, can we call them measures of outcome? And are they the same thing with effect size? I mean, I don't know.
Okay.
Can we say measures of outcome are the same thing with effect size?
Okay, no, cannot. So so here, let's illustrate this. Let's see if I can pull this up.
I'll get back to them in a meeting.
Alrighty. So here we have our outcome. And here we have our groups A and B. Oops. So these are the two groups in our study, A and B. Oops. Well, I'm sure you get what I'm trying to illustrate. So here, when we say your question was, let's explain. OR. Oops. This is such a nightmare drawing with this thing freehand. OR. So OR is 2.0. All right, so your question was, can we call this measures of outcome? No, we cannot. This is the outcome here. Let's say lung cancer. These are the two groups we're interested in, exposed versus non-exposed. A is exposed, B is non-exposed, right? I will find that the odds of lung cancer is 2 times higher among those exposed and non-exposed. Measures of the outcome are simply telling us how we measure the outcome. So measures of the outcome would be, for example, self-reported lung cancer or clinically diagnosed lung cancer or chest X-ray of the lung cancer showing clear evidence of lung cancer or metastasis. Those are different measures of the outcome. So for measures of the outcome, what we're referring to are what are your primary outcomes and what are your secondary outcomes. Those are the measures of the outcome. Now, this is also not the same as the effect size. The effect size is the minimum difference we want to detect between the exposed and non-exposed, right? We talk about effect size before we have conducted the study, right? Effect size is the term we use before we conduct the study. We're trying to say what oh, geez, when we conduct the study, right, what is the minimum difference we want to detect between group A and group B? Before the study, you've not done the study yet, right? That is when you talk about the effect size. It is what you use also to calculate your sample size, right? So you're like, okay, we want to detect this effect, and so based on that assumption, this is how many people we're going to need for our study. Oops. So that's what effect size is, right? Now, the measure of association is what you get after the study, which is the odds ratio of 2.0 here, right? This now comes after the study. So effect size before the study, we use it to calculate sample size. The smaller the effect you want to detect, the larger the sample size you're going to need, right? And then when we did the study, we collected data, we did our regression analysis, we now found this odds ratio. When you're doing your meta-analysis or your review, this is what you're going to be extracting, is the measure of association. So this is the measure of the outcome, this is the effect size, and this is the measure of association between the exposure and the outcome. I hope that is clear.
Thanks, Dr. Kaku.
Okay.
Is this a proper research question? What is the mechanism of memory decline in alcoholism?
What is the mechanism? No, it's not a full research question, because it's missing pi. The P in PICO, population. Is it among adults in South Africa? It's because the context is different, right? So again, try to include all elements of PICO where possible.
Thanks. Margaret, you asked about the steps you want to take when you want to start a systematic review. I suggest you watch the recording so you can get all that information.
Thank you very much, Lungli.
Okay, so Samson.
Thank you, Prof. Yes, quick one. I must appreciate your tenacity and your doggedness. I've been following you for the past 7 months right now, and I must appreciate you. I want to ask about predictive research and predictive review. Can systematic review analyze predictive research or predictive review? This is what I'm saying. I'm in the sciences. I'm an environmental and applied microbiologist. And we have the in vitro research and we have the predictive research, which we can use either through molecular docking. I want to know the role of systematic review in predictive research. Where can this systematic review analyze what we can do in the laboratory in an exact manner, getting a data, and then that is that. I'm really having issues in trying to correlate systematic review and rapid review. I get you said that it is done, systematic review is more of two variables. I've seen people analyze rapid review as a brief report. So I really want you to really share more light on that if time will permit, or by tomorrow we can continue from there. I will have to wait for now because I know you should rest because you need that rest. Thank you.
Okay, thanks. So regarding your second question, you are conflating a research approach with a report, the length of a report. There are different. So a brief report doesn't, saying something's a brief report doesn't tell us anything about, it has nothing to do with the study design. A brief report could be a randomized trial, it could be a cross-sectional survey, it could be a meta-analysis. A brief report simply means a report that is 2,000 words, approximately, in different journals long. And that could be anything under the sun. So we don't want to conflate the issues of methodology, which is, was this study a systematic review or meta-analysis or a cross-sectional study, with a report, which is just has to do with how a journal decides that it's going to publish things. So how you, as an investigator, decided that you're going to send your work for publication. Those are completely different things. Regarding your first question about whether I can include the types of studies, whether it's predictive or whichever types of studies, that is a decision that you, the investigator, has to make. Systematic reviews you can include anything under a systematic review, but that is why you as an investigator, you have to define what you want. So that is the question, not for me, but actually for you. You have to say, this is my research question. And as an expert in this field, here is what I'm going to do. I'm going to include studies based on this criteria. So there could be inclusion criteria, but you have to decide that. And then you have to tell us why you did that and justify it to us. But again, it's all very contextual and depends on the context, which you have to define with PICO.
Thank you, Prof. Okay, Ricky. Promise.
Hello, can you hear me?
Clearly.
Yes, we can.
I'm so sorry, Prof, for taking much of your time. Without wasting much time, please. The question I asked about case reports, I don't know if I think you missed it. So,
oh, okay.
Yeah. So I don't know if you can pick up on it, or should
okay. That's fine. I got it. So case reports are the bottom of the pool in terms of.
Prof.
Yeah, go ahead.
Sorry. So that now, second question is, how can I reference, or rather, how can I cite Chi-square? Because I know I use some other tools and I cite them. For example, the Prisma flow chart that has been developed by some folks. So I would love to also be citing Chi-squares as well. If there's any permission for that, I would really appreciate. Yeah, thank you.
Right. Yeah, great. So when you do, let's say you do is like the sample size we did. Let me remove this from here. Let's just redo this, for example, to recalculate this, and when you click on show reference, you can copy citation, which tells you, it essentially allows you to just copy that citation and use it directly in that work. So that's how you can use that. The mechanism to cite is already there. So for example, in this case, this is the citation. Regarding your first question about whether you can include case reports in systematic reviews, remember that systematic reviews are inherently quantitative. Meta-analysis systematic reviews are quantitative in nature. Case reports are essentially studies on one person. It's a one-man study where we're saying this individual. So case reports are in essence qualitative studies. They're at the bottom of the people. You can only calculate something like a percentage when you have at least two people. If you can't calculate percentage on one person because the denominator is one, right? And so for that use case, another kind of design, but it's kind of hard to do a systematic review when you have only case reports because it doesn't just match the design, the input and the output don't match themselves. You are looking at something that is purely qualitative with no numerical values, and you're trying to do something that is inherently quantitative, so that will not work. All right, Lungi, next questions, please.
You still want more questions?
No,
Okay. How about case series?
What did you say?
Promise, you want to?
Yes, sorry.
You
Yes. How about case series? Because case series will have it's more than 2 or 3 cases. So when you have case series and you're working on them, can you include them in systematic review?
All those questions are your own questions to answer. You are the investigator. So you should feel empowered, right? As the investigator to say, this is, any quantitative study can obviously be included in a systematic review. You as an investigator should feel empowered to say, here is my study. Here is the kind of studies, here is the inclusion or exclusion criteria, and you should be able to defend why you're doing it, right? And so those are questions that actually you should be telling us, not the other way around. But yes, you can include it. Now, why you include it, that's why you have to justify to us during peer review. I hope that is clear. So yes, you can include it. but you have to provide justification for why. It depends. It entirely depends on your PICO framework.
It's happy.
All right.
Thank you so much, Prof.
Happy, I'm happy there.
Thank you so much, Prof. Thank you, everyone. Thank you, Prof. Hamidu. You've been posting and responding to people's questions. Thank you so much, team members. Thank you, everyone who has stayed until the end. Thank you. And we will. I hope you all have the record. I hope you all have the links. The recording is on YouTube.
Look at what happened to your network.
I don't know if there's anything else you need. Dr. Gaku, do you have any last words?
No, I have none. I just need a stiff drink.
My network.
Yeah, you're breaking. I'll say you're breaking.
As usual.